Bismillahirrahmanirrahim. Assalamu alaikum. Today I am going to start a first chapter of this book of physics, which is physical quantities and measurement. First of all, I will introduce you to the very important branch of science, which is physics. In physics, we study about matter, energy, and their interaction. Okay, you are very much familiar with the word matter, which means anything that occupies space and have mass, and energy, the ability of a body to do work. And their interaction means that the combined effect of both, which means that everything around us have physics. In our daily life, we find hardly any device where physics is not involved. Consider pulleys, which lift heavy weight loads. Electricity is used not only to get light but also the mechanical energy. Consider the means of transportation such as car and aeroplanes, domestic appliances such as air conditioners, refrigerators, and many appliances at your house. TV, telephone, computers are the results of the applications of physics. Moreover, we can say that there is nothing around us which does not involve physics, which shows how important to study about the physics. Due to the involvement of physics in every field of life, it is divided into several branches. Some of them are mechanics. It is the study of motion of the objects, its causes and effects. For example, speed, velocity, acceleration, etc. Next is heat. Heat is a form of energy. It deals with the nature of heat, mode of transfer, and effects of heat. Sound. It deals with the physical aspects of sound waves, their production, properties, and application. Light. It is the study of physical aspects of light, its properties, working, and the use of optical instruments. There are many optical instruments, which are lenses, microscopes, telescopes, etc. Electricity and magnetism. It is the study of charges at rest and in motion, their effects, and their relationship with magnetism. The next branch is atomic physics. It is the study of the structure and properties of atom. Then, nuclear physics. It deals with the properties and behavior of nuclei and the particles within the nuclei. Now, plasma physics. Plasma state is the state of gas at very high temperature. It is the study of production, properties of ionic state of matter. It is also known as the fourth state of matter. Last but not the least, geophysics. Geo means earth, so it is the study of internal structure of the earth. Now I will tell you about the physical quantities. All measurable quantities are called physical quantities, such as length, mass, time, temperature, etc. A physical quantity possesses at least two characteristics in common. One is numerical magnitude and the other is unit. Numerical magnitude means any number, 1, 2, 3, 4. Unit means meter. So whenever we have to describe some physical quantity, we can explain it in terms of 1 meter, 1 centimeter. For example, if the length of a student is 104 centimeter, then 104 is a numerical magnitude and centimeter is the unit of measurement. Similarly, when a grocer says that each bag contains 5 kg of sugar, it means 5 is a numerical magnitude and kg is a unit. Now we will discuss about the types of physical quantities. As there are several physical quantities around us, so physical quantities are divided into two types. One, base quantities, and the second is derived quantities. Base quantities. There are 7 physical quantities which form the foundation for the other physical quantities, means all the other quantities are expressed in terms of them. These physical quantities are called base quantities. These are length, mass, time, electric current, temperature, intensity of light, and the amount of substance. All these physical quantities are chosen by the scientist arbitrarily, like there is no specific reason for there to be chosen. The table 1.1 is of physical quantities and their SI units with symbols is taken from your book. The names are length, the symbol is L, the name of the unit is meter and its symbol is M. The second is mass, the symbol is M, unit is kilogram and the symbol is kg. The third one is time, symbol is small t, unit is second and symbol is small s. Fourth one is electric current, the symbol is I, unit is ampere and the symbol is capital A. Intensity of light, symbol is capital L, unit is candela and the symbol is small cd. Temperature, capital T is the symbol, Kelvin is the name of the unit and capital K is the symbol for the unit. Amount of substance, small m, mole and the symbol is MOL. The units of the base quantities are known as base units and each have the SI units. As we have already studied that every physical quantity has the characteristic that it should have a numerical magnitude and the unit. The other type of physical quantities are derived quantities. Those physical quantities which are expressed in terms of base quantities are called derived quantities. These are area, volume, speed, density, force, work, energy, power, electric charge, electric potential, etc. And the unit of such quantities are known as derived units. Just like derived quantities, the units of the derived units are also expressed in terms of the base units, like they are obtained by multiplying or dividing one or more base units with each other. For example, the unit of area is meter square and the unit of volume is cubic meter, are based on the base units, like length, which is meter. Thus, the unit of length is base unit, while the unit of area and volume are derived units. The table 1.2 from your book is given the derived quantities and their SI units with symbols. The quantities given are speed, acceleration, volume, force, pressure, density, and charge. The names of the units are, for speed, it's meter per second. For acceleration, it's meter per second per second. For volume, it's cubic meter. For force, Newton. Pressure is Pascal. Density, kilogram per cubic meter. And for the charge, it's Coulomb. The symbol of the units are also given in the table. I hope you understood what I have taught you. Thank you so much.